When choosing between messaging queue and a VMQ, we often get confused. So in this video, I'll try to explain about the virtual machine queue. So before we get started, I have placed the video timestamps in the description so that you can navigate to the topic that you're interested easily. So let's get started. Let's understand the need of a messaging queue. Let's take an e-commerce platform for the example. So I have a user who has already checked out his products from the shopping cart and entered the banking credentials, and then he calls the order service. The order service takes the details and calls the payment gateway for getting the payment. Once the payment is completed, the status is being persisted to a database, and the transaction over here is complete. But do you think the moment you place an order, the order comes at your doorstep the very next moment? Of course not, because only some part of this journey is a synchronous process, whereas it's a very huge workflow which involves multiple systems, and those might take days or even weeks. So this cannot be a synchronous process throughout its journey, right? It has to be decoupled and it will be asynchronous, which might run for days or even weeks. So what happens when the order is placed in the database? This database is polled by another service at a particular interval of time. For example, over here, the database is being polled by the fulfillment service at a particular interval of time, and then the fulfillment service takes the decision whether to go with the order, reject the order, and in case if we have to go with the order, it has to transfer it to some shipping services, right? So this is a complete workflow. If I show you, this is the bigger picture where we have a shopping cart service, order service, fulfillment service, delivery service, and notification service. So all of these services work independently, but ultimately they are being orchestrated by an orchestrator. So what is an orchestrator over here? This is basically a business process management tool which is being done by tools like Camunda, Activity, or the TIPCO business process management, right? So they will orchestrate all this process, and there is a state management going in between the processes, right? And this run for a long time. So this is the bigger picture, and they don't run synchronously. Some parts might run synchronously. For example, the order service getting the data from the payment service, this is synchronous, but other things are asynchronous and might even takes days or weeks to complete. So this is what happens. Now let's come back to the smaller part that we are focusing on, that is the order service and the fulfillment service. Now this was for prepaid orders, right? Now what happens? The company realizes that they also want to give a cash on delivery option to the customers, and they have been giving this option to the customers. But what they observe is the COD orders are unreliable, which means that they either get cancelled at the very next moment of the order, or when the order is delivered to them, they do not pay the amount, right? And the order gets returned back, right? So in such cases, what do they realize? That having a DB doesn't make sense, or it is not cost effective. In this case, why do we have a DB? Because this is a prepaid order and we need to keep a track of those orders, right? In case if the fulfillment service rejects order due to some logistics problem or out of stock problems, right? So we should be able to reverse the payment, right? But for COD, we do not have any payment in hand until and unless the order gets delivered, right? So that makes a little sense to have a DB and persist all the records, because DB is a permanent persistence, right? The record stays there for a long time. So what is the need over here is there are two services which run asynchronously, right? From here, that is what we can understand, that the fulfillment service doesn't run synchronously with the order service. It runs asynchronously. It is polling the database at a particular interval, so it's not synchronous, right? And the second requirement is that we need some temporary persistence, not a permanent persistence, but a temporary persistence. And the third thing is, we do not want to lose the order either. We do not want to lose the COD orders also. Even though they are unreliable, they can get cancelled, but ultimately if they get honored, they'll generate a revenue, right? So we do not want to lose that order either. So what we can do is, we can use a messaging queue. Messaging queue fits all the three parameters that we want. Like, first one is that it provides you a temporary storage, right? Second one is it provides you reliability. We'll understand in a few moments that how it provides reliability. So you push the message to the queue. And third is it helps us in making the process asynchronous, right? So we use the messaging queue. Then, to understand the reliability mechanism, we have something called as a dead letter channel. We'll understand that. And the fulfillment service can either push the message to the dead letter channel or dead letter queue. And also the messaging queue can directly push the message to the dead letter queue. So here we understood the relevance of a messaging queue. Why do we need a messaging queue? There could be multiple other applications of the messaging queue, but this is one of them, right? So let's move to the next slide. Now here we'll understand how does messaging queue helps us in getting the reliability pattern, and then we'll switch our focus to the VMQ, right? So we just focused on order service and the fulfillment service, right? So in the last slide, we saw that a messaging queue was connecting both the service, and we also came across something called as dead letter queue. Now let's understand what is a reliability pattern. For example, the order service receives an order, and since the fulfillment service and order service are using a messaging queue, you push the order to the messaging queue. Now the fulfillment service consumed the messaging queue message and sent an acknowledged message that okay, fine, I have consumed the message. But later on, while processing the order, what happens? The message fails. So what has happened? You lose the message, right? Because the message failed. So you come up with the second approach that okay, until and unless I process the message successfully, I won't send an acknowledgement message. So until and unless the acknowledgement message goes back to the MQ, it won't delete the message from the queue, right? So that is fine. But even after processing, the message fails. So your ACK acknowledge doesn't go to the MQ anytime. So it keeps on processing. So how long should you process, right? Because it's failing every time, and you don't send ACK message and it gets timed out, then the message still stays there. Then again it pulls the same message and it fails. So it will become an infinite loop of failures and the message will never get processed. So we have to put some limit, right? Process it 3 times, it fails, then do not process it. So what we do, we put a limit. You can either put that limit on messaging queue. It's usually put on messaging queue, or you can handle it on fulfillment service. Many messages queue come with this ability to define a limit in themselves, but if they do not, you have to handle it in your service or the code that you have done, right? So suppose we put a restriction of 3 attempts of delivery, right? And if those 3 attempts of delivery failed, then what we will do, we'll push the message to the dead letter queue or the poison queue. Why the name is poison queue? It is because the message is poisonous. It cannot be consumed, right? So we push it to dead letter queue or the poison queue. So it can either be directly done by the messaging queue, or you can have the fulfillment service do it manually, right? So that is the concept of reliability. We are in this way, we are not losing any messages. So what happens in DLQ? Someone can externally access, like someone from the support team, he can externally access this dead letter queue and look at the message, and whatever the corrective action has to be taken, they can decide it. So we are not losing any messages in this case, right? And that is what the reliability pattern is, right? And we have created the reliability pattern using the messaging queue. Now let's think the other way around. Like, we have the messaging queue, and usually this messaging queues are backed by a broker, right? The broker takes care of sending the messages to messaging queues. So suppose the broker is down, or the whole messaging queue is down, right? Now the order service, if it wants to push the message to the messaging queue, it won't be able to push the messages, right? And again, you might lose the messages, right? Because it was unable to push the messaging queue. The second problem over here, why it is not able to push the messaging queue and why it can go down, is because the messaging queue is not as part of the same code or the same runtime. The order service will be part of a mule runtime, fulfillment service will be part of a mule runtime, but the message queue is some another application, so it may go down, right? And we do not want an extensively featureful messaging queue. Like in this case, we are having a feature rich messaging queue which allows you to configure a dead letter queue, which allows you to read the messages externally, right? We want a very simplistic queue. Depending upon our requirement, we want a very simple queue. We do not want all this feature. We just want to decouple two flows or two services. So we do not want this hefty messaging queue. So what we can do is we can use something called as an in-memory queue, which is also called as VMQ, right? So we have a mule runtime, and both the services or both the mule apps are in that single mule runtime, and we have a VMQ. So the VMQ is part of the same mule runtime. So there's no question of the VM going down. If it all goes down, everything will go down, right? The order service and the fulfillment service and the VM together. So what we did, we made the VMQ as part of the mule runtime itself. So this is an in-memory queue. Now remember, two apps can be deployed to a same runtime only in case of on-premise systems. And the other condition for this is that the VM connector that we are going to configure for this two service should be part of a domain project, because so that both of them can use the same VM connector configuration and the queue can be shared between these two mule applications. So these are a few points that you should keep in mind, right? So now we understood why do we need a VMQ. When we have a very limited usage of queue, like we do not want a full-fledged queue, we can go with a VMQ. The decoupling is our only concern, and we want some sort of reliability. Now there are again two aspects to this VMQ. You have a persistent VMQ and you have a transient VMQ. Obviously, the persistent VMQ provides better reliability as compared to the transient VMQ. But the trade-off over here is that it comes with the speed cost. The transient VMQ is faster, obviously, because it is in memory, which is stored in the RAM or the heap space, whereas the persistent VMQ is stored in a file system. Okay, so those are the two aspects to the VMQ. Now let's move on to the next slide and analyze the VMQ working in a cluster of on-premise runtimes, right? So let's suppose we have a cluster of 3 nodes. Nodes means virtual machine or a physical machine that you have, and we install mule runtime on all the 3 nodes, right? And all the runtimes have order service and a fulfillment service deployed to them. All the 3 nodes have those services deployed to them. Now let's understand how the VMQ behaves in case of cluster of nodes, right? So in such cases, the VMQ is backed by Hazelcast VDSM, which means virtual distributed shared memory, right? So what actually happens is this VDSM is not outside the 3 nodes, right? It's a shared memory grid, but it's effectively inside the 3 nodes. Like you do not have a third system created to host this VDSM. So what happens over here is that it gets replicated in either of the two nodes, right? At least if you have a cluster of node, it has to be present in at least two nodes. Why? To get reliability, because if it is hosted on a single node itself, the shared memory grid comes on a single node and it goes down, so we do not have the messaging queue left for node 3 and node 2, right? So it's effectively replicated, and Mule takes care of replicating the data between the VM which is present on the both the nodes. So at any given point of time, the messages will be in sync in both the queues. It won't happen that you have one message persisted over here and you do not have the message over here. Everything will be in sync, so both the queues will be sync, and that the number of replications of this queue depends upon the quorum size. You can manually also configure this quorum size depending on the properties that you added, right? So here both the VM queues are replicated, and now when the order queue pushes the message to the fulfillment to the VM queue, it's being consumed by the fulfillment service. Same for the node 2, and node 3 in this case does not have a replication. So what it will do, it will consult the VM queue present in either the node 2 or node 1 in this manner, right? So in order case has to push it, so it will push to the node 2, and if fulfillment service has to receive, it will retrieve from the node 2 VM queue. So this is how things work in an on-premise cluster. One more point to note, that on-premise cluster does not give you a facility of in-memory VM queue. It only gives you a persistent VM queue facility. So that is another point to keep in mind. Now let's go to the Cloudhub VM queue. Now the dynamics change in the Cloudhub system. Now if we observe, we have 4 workers, which means that the application has been scaled horizontally. And the another thing that we observe is we do not have a fulfillment service over here. So what do we understand? That if you have 2 different Mule applications, all right, and you try to give the same queue name and everything in their configuration, the second app and the first app cannot use a common queue. That's the main funda over here. So you cannot have 2 different apps on Cloudhub accessing the same VM queue. So that is a limitation. Why? Because all the workers have their own Mule runtime, and each different app is isolated from each other, so they cannot access a common resource over here. But if the same application, I repeat, if the same application is scaled horizontally, in this case the orders application is scaled horizontally across the 4 workers, they can access the same VM queue. Okay, so what I've done is, the order app itself has a publish and a subscribe flow. One flow publishes and the other flow subscribes. So it has a listener and one has the publisher, right? And same thing has been replicated across all the workers. So in this case, the VM queue will be hosted to an Amazon simple queuing service, right? If you enable the persistent VM queue, it ultimately goes to the Amazon SQS, and from there it can publish and subscribe. So you publish it, so the next flow will be able to is already subscribed to that messaging queue, and it consumes a message from there. So the difference is, in on-premise you can have multiple applications which can consume a same queue, but on Cloudhub you cannot have multiple application, but you can have a single application, and it can also be horizontally scaled and they can access the same queue, but multiple applications cannot do that. And in on-prem, the messaging queue is done by the Hazelcast VDSM, whereas in this case it is done by the Amazon SQS, right? So these are the differences between the Cloudhub VM queue and the on-prem VM queue. Now other use of this VM queue is, it can also help in load balancing, right? How it can help in load balancing? Let's try to understand. Suppose this is node 1, node 2 and node 3. All of them have the same application. flow 1, flow 2, suppose they are connected with a VMQ. So this publishes to a VMQ and this one has a listener to that VMQ, right? So let's assume that flow 2 of node 1 was busy. Flow 1 published the message to VMQ and flow 2 was busy. So it sent the message to the flow 2 of node 2, because all the listeners, suppose we have listener in flow 2, flow 2, flow 2 of node 1, 2 and 3, right? So all the listeners are listening, right? So it's basically a competing consumer pattern, like everyone is trying to get quickly the messages from the VMQ. So maybe the flow 2 listener was quick enough to get the message from VMQ, so it took the message, but then all of a sudden it realized that it is busy and it cannot consume the message right now. So what happens? Instead, the flow 2 consumes, right? So what we have done, one part of the message was processed by the flow 1 in node 1, whereas the second part of that message got processed by the flow 2 in node 3. So what we have done, we have done load balancing. If your flows are busy, you can transfer the flow to another node in the cluster. So that is yet another use case where you can look for a VMQ if you want to load balance the request. Now, one more thing, that the VMQ is also used by batch processing. So it is being used in the load phase. So let's understand how it uses. So anything in the load phase, what happens, it creates a record queue, right? It splits the messages, splits the huge array into multiple messages and then loads the messages into the queue. And this queue is nothing but Amazon backed SQS. This is in case of Cloudhub. Remember that it is in the case of Cloudhub that it is backed by an Amazon SQS. So what happens? All of this record will get persisted to Amazon SQS, which again is an application of the VM connector, right? So over here also the persistent queue takes place. Whereas if it is on-premise machine, ultimately the persistent queues will be your file system. So it gets loaded into file system. And that is exactly the reason, like if you are processing like 1, 2, 3, third record, and at the fourth record, the runtime got crashed, either in on-prem or Cloudhub, it got crashed and you restarted. So it will read from the fourth. It won't happen that everything will be lost, right? Because the persistent queues were loading all the records and they have the track, so the records were not lost and it starts from where it stopped. So again, this is a reliability pattern that has been implemented over here. So that's the reason the batch processes sometimes take long time to process the records, because there is again a network call, right? If it is on Cloudhub, there is obviously a network call to Amazon SQS service which will take the message and then return the message. So now that we understood the concepts behind a VMQ and its few use cases, let's try to perform some operations using the VM connector. So first of all, I will do a publish operation wherein I'll publish some message to the VMQ. For that, I have a transform which just creating a basic JSON with key as hello and value as world, and will publish this message to the VMQ using the VM publish connector, right? For that we need to configure the connector. So we'll go to the VM config, and over here what I have done is I have created a queue, and for queue you have two options. One is a bean reference and one is edit inline. When you choose bean reference, you have the flexibility to give your own implementation of a VMQ, and you have the freedom to give any kind of your personal implementation, right? A custom implementation can be done, and you have to give the reference of the Java class or object that you have. Otherwise you can go with the plain version that Mure provides by default, okay? And you have to create a queue, so you give a queue name and queue type. Let's just click on this, or you can use the plus option to create one. So you have to give the queue name, you have to give the queue type. Queue type is what we discussed in the slides. There are two, transient and persistent. So transient is by default, which means that it is in memory and it is faster than the persistent, right? persistent, it basically uses your disk space. So let's just first go with the transient and then go with persistent, right? And max outstanding message means how many messages are allowed to be queued, right? So here it's 0, so that it won't allow more than one message to be in the queue waiting, right? So let's just click on finish and hit OK. So we have the VM config ready. Now we are publishing, and what content are we publishing? We are publishing the payload, right? And we give the queue name, it automatically comes. If you refresh this in the list, it comes as in, and the timeout is 5 and the unit is seconds, so it will wait for 5 seconds. If it is unable to publish in 5 seconds, it will just time out. You can edit this as per your requirement, right? And after that, I have a logger saying that message has been published to the queue, and another logger just logs the payload that we published to the queue, right? So let's just run this demo and see what do we get. So the application has been deployed successfully, and we'll try to hit it, but let's see this flow. In this flow, we are just publishing, right? We have nothing to consume, so we won't be able to actually see the messages. And since it is a VM queue, so there's no provision to externally view the messages in the queue. So that's a problem over here, right? So what we can do is we can now just hit, this is the endpoint that I've exposed, it's VM at port 8081. So let's just trigger, and we get the response as hello world, because that is what the payload where we have pushed to the message queue, and we see the logs, we get the message published to the queue. Right now we don't have any mechanism to manually go and check the queue, right? So basically we need to have a consume connector which will able to consume the queue, or we can use the listener connector. So what I'm gonna do is I'm gonna use a listener connector in the next flow, right? And just no, not socket, it should be VM. So we'll drag and drop the VM listener connector and use the same VM config that we used to publish, so that we are able to get the queue. And in queue name I get the in queue. All right, and in the response we can set a custom response if we want, or it can be payload also. So let's give a custom response, right? So let's output application JSON and message equal to success. So let's save it, so the application gets redeployed, and let's see what do we see, what do we get. And in this I have a logger, and the logger says message received, and it's printing the payload that we received from the listener, right? So the application got deployed, and we don't see any logs, right? Nothing got triggered. Why it didn't get triggered? Because when we redeployed, the message in the VM queue was lost, right? Like we know, because we use a transient VM queue, the message got lost. So even when we redeployed and there was a listener, it was unable to read the message. So what we'll do now is, let's just delete this listener again, okay, and make the queue as persistent. And after making persistent, we'll publish the message to that queue, okay, and we'll again add a listener and restart it. So let's just make this as persistent now. Let's hit finish, okay, and let's just save it. Alright, the application is getting redeployed again, and it's redeployed now. What I'll do, I'll trigger the flow again, and yes, the message was published to the queue. As we can see, message published to the queue. Now what I'll do, now let's add a listener over here, VM listener, right? And it listens to the in queue. It uses the same VM config that we have used for the publisher, and in response let's just add application JSON message success. Let's just save this so the application will get redeployed, and we should be able to see the hello world message that was previously pushed to the queue, since it is a transient queue now. So let's check the console. It's getting redeployed, and what do we see? After redeployed, instantly we get the hello world message, right? Because this was a persistent queue, we were able to get the message. So what does this signifies? This signifies that if you use a persistent queue, it will survive any restarts. Yeah, so that is the significance of having a persistent queue. Now what we'll do, we'll add a publish consume. We also have a publish consume. We know that what consume does, consume can be put apart from the source, it can be put inside the flow and it will consume. And we know listener, we have used it. We also know publish, but let's see what is this publish consume, right? So let's just drag and drop this publish consume and remove this publish first of all. All right. And what we'll do, we'll see publish consume is used when you want to publish the message to the queue and also want a response from the person who consumed the message from the queue. For example, this publish will publish to the in queue. The data hello world will be published to the in queue. And when this listener listens, consumes the message from the in queue hello world, it can set some response. Like in this case, it is setting the response as what? It's message success, right? So this message success will be sent to the publish consume. This will get that message and it will forward that message. That is the job of a publish consume. So it publishes, it does the job of publish, but also waits for the consume response from the listener or any consumer. So let's just see this in action. So what I'll do, it is already configured. I just need to give an in queue name, and again the timeout is 5 seconds. So yeah, that's pretty much. So instead of hello world, I should get the other message, right? The success message. So let's just save this and let's see what do we get. So the app got redeployed. Now let's refresh and see, we got a message success, right? So what do we see in the logs? We see that message was received by the first flow, then it got published, the message hello world got published, and then in return what we got the message as success, right? So this is what is the role of publish consume. And if we, what happens if we remove this listener? Let's try that as well. So it's again getting redeployed. Okay, it got redeployed. Let's try to trigger it again. And it's taking time this time. So what did we get? We got published messages to queue in queue, but got no response after timeout. So if your publish consume gets no response, so it will give the error, right? So ensure that if you are using publish consume, it expects a response. If it doesn't, it gets an error. So it's always that it publishes and expects the response from the listener or the consumer who consumed that to return a response. Unless we get the response, it will give a timeout error. Now the another thing that I want to show you is that we use a persistent queue, right? And we're using the publish consume, we have already published the message to the queue, right? So it's not yet consumed. So we should be able to see this message in a file system, right? Because it is a persistent queue. So what we can do is we can navigate. You have to go to the location where your Anypoint Studio has been installed. In plugins, you'll find a tooling server, or optionally you can use the mule home variable and you can locate this, and then in mule you find the .mule folder, and that has the application name, right? and then it has something called as a queue store folder. So you go to that queue store folder, and we see that we have something called as in queue 1, right? So this is where all the messages are stored, right? So like I said, it cannot be the messages cannot be accessed externally. Yeah, they can be accessed, but it doesn't make sense. If I open this file, see, it's all junk values. Can you even understand? It's all serialized objects. Although I can see that hello world message into this, but most of the things do not make sense, right? So there's no point of even having this file. You cannot read it on your own. This needs to be deserialized and then be consumed. So that is the problem. These messages cannot be consumed externally or can't even be re-triggered. You need an application, mule application, to do that stuff. So yeah, so that's the limitation that a VM has as compared to a full-fledged messaging queues, because it's a stripped down version of a messaging queue. Now I want to also demonstrate the same thing on Cloudhub. So what I've done is I've created two apps. One is demo 1 VM and demo 2 VM, and both of them have exactly the same VM configuration, but since they are two different apps deployed on Cloudhub, they won't be able to share the queue. So just to demonstrate that, I have deployed two apps with the same VM config to Cloudhub. So here are the two apps, VM1 and VM2. Okay, now first I also want to show you that I have enabled the persistent queues to the VM1 and VM2 apps. So this is the VM1 log and it has been deployed. So let's see the VMQ configurations that we have over here. So whenever the application is getting deployed, so I've scaled this horizontally across two workers. We'll come to that later on, but first let's compare the VM1 and VM2 app, the persistent queues that got created for them. So if we see, we have registering the queue with name as 8GOP5112, right? Something like this is the queue ID, and the name is a in queue, right? So this is the queue ID that we have. And if we go to the second VM2 app, this is the VM2 app, and if we see the queue ID, it's different, right? So even though we had the same queue configuration and also the name, it generated two different queues. So this means that two different apps cannot share the queue in Cloudhub, right? But the same thing can be done on premise system using domain projects, and they can also be shared across a cluster of nodes, right? So this is one difference. And yeah, if you scale the same app, like if you scale the same app VM1 horizontally across the horizontally across two workers, like I've done worker 0 and worker 1. So this was the worker 0 deployment that happened. Okay, and if I scroll down, I also have the worker 1 deployment. If you see, this is worker 1, right? And previously it was worker 0, and I did a couple of push and consume from the queue as well, and then I scaled it across two workers, so it's worker 1 now, and it's deploying to worker 1. And if you see again, it uses Amazon SQS. It's showing that bucket ch persistent queue, US prod access key, and all those stuff, and you get new SQS client is created on Amazon AWS. So this shows that it creates an Amazon SQS for persistent messaging queue. But the main concern over here is about the queue. So if we see that both the workers have the same queue ID, right? So if the same app is scaled horizontally, it gets the same queue ID. But if two different apps are there, they get different, so the different queue ID. So queues cannot be shared. But here, in case of the same app which is scaled horizontally, we can share the queues. So this is what we can see in the Cloudhub logs, right? So that is what you should keep in mind. That's the main difference between on-prem and the Cloudhub hosted queues. So I hope you might have found this video useful, and it might have cleared many of your doubts regarding the a full-fledged broker-backed messaging queue and a VM queue, and also it might have give you some insights of how does the queue behaves on VMQ behaves on premise and on CloudHub, and what is the difference between an in-memory and persistent VMQ. So you can take your decisions accordingly while creating your projects. So I hope you found this useful. Thanks for watching.